All right, it's Chinese kit time. SKU 905258. What is it? I don't know. Let's get it out onto a tray. It's not very big. Ah, I know what this is. The high voltage thing. Makes high voltages. And it's got weird scotch tape on it. I don't know why. Get that off. Yeah, it's got a cool transformer and it's got multiple leads on it. Interesting. It's got 2 heavy leads and 2 thin leads. So why does it have 2? That's a good question. One of them might be a feedback for oscillation, and one of them may be the actual signal, but it's got 2. Oh, this is not lined up right, is it? There we go. I'm sorry. Yeah, it's got 4 wires on that side and 2 wires on this side. So these are the high voltage wires, and these are the input wires. So, all right. PC board, single-sided, reasonable quality, FR4. No instructions. Comes with a little heat sink and some type of transistor. Let's see if this has a marking on it. And nope. This is a mystery part. Mystery part. So let's go ahead and use our component checker and see what kind of part it is. It's an NPN, HFE of about 300. So wacka wacka. These things are usually good for, I don't know, 1 to 3 amps, something like that. All right. So it comes with a switch. Let's get this back over here. Comes with a switch. So let's see, how do I go about doing this? I think I want to mount the transformer last. Oh, the cable ties to hold the transformer down. So let's go ahead and put on the transistor and the heatsink is soldered down, and then we'll put that on, and then there is a diode, a 1N4007, 120 ohm resistor. I saw that somewhere. Here it is. 120 ohms. And that's it. Wow, that is it. Wow, not many components. So. Wow, I'm amazed. Nice switch. I don't know why there's a switch on it, but okay. Yeah, let's start building it. So this is one of those kits I would not give to a, I don't know, would not give to a minor. I think it's going to be dangerous. So. Build at your own risk. I think it's something like 15,000 volts or I don't know, something ridiculous. This is one of those things that mothers always wonder why boys survive their childhood. Like every boy goes off and does something that probably should have killed them, but didn't. Or broke 16 bones, but didn't. All right, let's, wow. Yeah, let's put on the heatsink. course, the world's gotten to be a safer place because they've banned all of those things that usually can kill you. Just last week, my wife asked me, when you were a kid, did you have a Gilbert chemistry set? Yes, of course I did. And some article was talking about how dangerous they were, how they've been banned, and I've got to move the camera here to get into a drawer, sorry. And of course I had one, of course. So I'm going to put some heat shrink grease. Sorry about me in front of the camera. Okay. So I'm going to put some heat shrink grease on this because I can. Oh, it's starting to separate. Let me mix this up. It's kind of hard at the bottom and very, very soft at the top. So, time to mix it up. Uh-oh. And time to break off the stick in the goo. So let me throw that away so I don't get it all over myself. All right, where am I? All right. Some heat shrink on here. Heat sink grease. Should be good enough. Throw that away. Close this up. This stuff gets everywhere. All right. Let's put this on. It even comes with a little screw. The heat sink is tapped. And the screw goes in. All right. Oops. Oh, jeez. Do you see what I did? Can you see that? Anyway, it's all crooked in there. I kind of tightened it a bit too much, so let's straighten out this. I've never done that before. Never, ever, ever. Kind of strange. Must be really, really soft leads on these Chinese transistors. So straighten that out. Tighten this up, and it's going to do it again. So let me wedge something in there so it can't. And now I need 6 hands. All right, good enough. Close enough for government work, as they say. All right, let's go back over here. Are we focusing? I don't know. It seems like there's something shiny. Ah, that's better. Sorry for the lousy camera work. I thought this was going to be a super short build, so I wasn't paying much attention to anything. I'm doing laundry at the same time, so beeping sounds in the background as things going off. All right. There we go. What's next? Let's see, there's a place for a power connector, but there is no power connector on this thing. Huh, interesting. Place for wires to solder on. And, all right, now we have to figure out the wiring of the transformer, which is a mystery. Well, it seems as though there are 4 holes in the PC board and there's 4 wires, and 2 of the wires are shorted together. And would that make any sense at all? No. How would that work? This thing's not center tap because they're different sizes here. This is really strange. Let's see if I can find a picture of somebody who's built one. Well, I can't figure it out. So it looks like my first impressions were correct, but I don't know why that would work. But if it doesn't work, we'll just have to move the wires around. Well, let's see what happens. I have to remove the insulation from these enameled wires. Need to get at least half of the wire. Some people use sandpaper. Some people just heat the heck out of them so the enamel dissolves, I guess. I don't know. I like to scrape them. So whatever gets it off. Okay. Oh, I guess I should have made them shorter. Let's put the cable tie on. Right. Honestly, I don't know why this would work, but let's see, we're going to whack that one. Power comes in here, power goes to the center, and then this is a takeoff. I'm going to think, oh gosh, I'm going to assume this other one, and that the takeoff is the little winding. That makes more sense to me. That makes more sense to me. All right. Engineering prowess says this is the right way to do it. And if it is, I get brownie points. Okay. Well, that's weird. Get the solder stick. All right. Oops. These wires are poking out. There we go. This is not easy to solder for some strange reason. Okay. Power. Switch. All right. Switch goes on. The data sheet said some kind of weird voltage on this thing, like no more than 4 volts or something input, so that's kind of weird. Okay, there we go. And then the power comes in, and all right. Let's see. Let's these together over here. In case it decides to do something. Okay. All right. Okay, so I think that's all there is to it. And if it works, we'll get a little zappy thing on the other side. So let's see if we can. Let's put 4 volts on it and see what happens here. Let's see which is plus and which is minus. Plus is towards me. All right, plus is towards me. So we can hook that one up. Well, that's hard to grab onto. So let's use their little supplied pins here. All right. Again, I need 6 hands. I need to be able to see under the board at the same time as over the board. All right, hold that on. All right. Then balance that and solder with this. And chew gum. All right, there we go. Close enough. Okay. Let's get another pin. Okay, it's all together. I got interrupted there, so I think the video is starting up in an okay place. So we have 3.8 volts coming in. I think this thing was meant to be something for a lithium battery, so it was designed around, 4 volt kind of thing. Anyway, so 3.8 volts coming in, and three components: transistor, resistor, and a diode. That's it. So I'll draw a picture of how I wired up the transformer. It's not clear. There wasn't any instructions exactly how to do that, so let me show you how to do that. Anyway, so I have I soldered on a little thing here with 2 points coming in, and there you go. Can you see? Let me put something dark. Put something dark behind it. What's dark? This is dark. Can you see the? You see that? Yeah, there you go. So there's a little arc there. And so let's turn this off. Let's measure that arc distance. it is about, oh, let's see, let's do it in millimeters. Millimeters are easier. 4 millimeters, so it's jumping 4 millimeters. And I don't know how much further it would jump. I found a, oh man, this is blowing the camera out. Let me, all right, so this is off of a Hackaday article. Spark gap to voltage. So voltages and spark gaps in centimeters. So we're about half a centimeter. So we're down here at the bottom. So we have ways to go if we get into 15 kilovolts. 10 kV is supposed to do, well, 15 kV is supposed to do about a centimeter. So if we can do a centimeter, we're getting up there. So let's come back up here. Just the camera again. There we go. All right. So anyway, I don't know how many kV this thing is. If it's 5 kV or more than that. I have a high voltage probe somewhere. Maybe I can find that. Might be an interesting thing to do. The spark. Let's see, can I get closer than this? Let me see if I can get closer than this. Yeah, there we go. How's that? Put something dark behind that. Cool. That looks good in the camera. It's a cool, cool color, and it seems to be more active at the electrical contact at the bottom than the top. It seems to be more vigorous at the bottom. So I don't know what that means. I'm not sure which is plus and which is minus and why it would make a difference, and I don't know. It's yeah, it's interesting. So let me draw a picture of how I wired it up so you can get it right. Let me see if I can first take a picture of it here. Yeah, that's not a bad picture of it. Let me turn this off so I don't zap myself inadvertently. Inadvertently. There we go. Speak today. All right. So there is a thick lead. So here's a thick lead here, and there's another thick lead, and then there's two thin leads. There's a thin lead here and a thin lead here. So the thick leads go from that hole to that hole, and then the thin leads go from that hole to that hole. Right. So that's how I have it wired up. So I guess I don't need to draw a picture. So if you are going to build one of these, that's the way to do it. So the high voltage is, I believe, generated with the primary are the heavy leads. So that's the primary, the transformer, and then they go off to these red leads, which are the secondary. And then there's an additional coil. That's these little thin wires, and that's the feedback path to kick the oscillator circuit to turn this transistor on and off. Yeah. And there's the other two components, the 1N 4007. There's a whole bunch of 4000 series, and the higher the number, the higher voltage rating. So the 4007 is a pretty high voltage rating, breakdown voltage rating. So, yeah, there you go. So I did want, now that we have it up and running, so when I first turned it on, it just started burning the insulation of the wires, and so I needed to add this so it didn't start melting. This is a really bad insulation for high voltage. It just started melting and stunk up the garage. So let's go ahead and see if we can't build a Jacob's ladder. All right, so let me describe what a Jacob's ladder is and see if we can't build one and see if it actually works with this thing, or maybe it's just too small and too boring. So, but let's give it a try. Okay, so Jacob's ladder is that the wires that are going to be the arc. If we have these two wires coming in here to do an arc, what we're going to do is we're going to then bring them up like this. All right. And so what happens is the arc starts to form at the narrowest portion, and it ionizes the air around it, and it's not as conductive as it once was, and it generates heat, and the heat makes the air rise, and so if it's built right, the arc will then move up because it's kind of depleted the oxygen underneath it, and it's now moving up, and then it will finally stop working, and then it'll start over again. So it'll go bzz, bzz, bzz. So you might see that in the old monster movies. Let's see if we can't build one of these. It's going to be a real tiny one, so yeah, let me get some wire and we'll build one of those. All right, there we go. We have a Jacob's ladder. Look at it go. It's traveling up kind of slow, kind of fast, I mean. So I think you can see that. Let me put my microphone on so you can hear it too. Yeah, very cool. I like it. Anyway, Jacob's ladder, cool little kit. They're super cheap, just a few bucks. Super dangerous. Please be very careful with this. There's no safeguards, there's no nothing on this thing. It's just dangerous as heck. But fun.